Welcome to The Explainer. I'm absolutely thrilled you're tuning in today. We're going to decode exactly how critical global port infrastructure is adapting to survive the escalating threats of climate change. Because whether we're talking about rising oceans or failing power grids, the logistical lifelines of our modern world are quite literally under siege. And that means everything from the cost of your weekly groceries to the delivery of your new electronics is on the line.
Take a look at this flooded port crane. Seeing this, the stakes of global sea level rise instantly shift from some abstract forecast into a literal, immediate crisis. Flooding of a port directly disrupts operations, it damages goods, and it can bring massive industrial facilities to a complete standstill for months. If these gateways go down, our global supply chains completely freeze.
Okay, let's dive into our roadmap for today. We're going to cover ports under pressure, then decoding climate resilience, rising tides in LA, powering through the storm, and finally, future-proofing global trade. Starting us off, Section 1, Ports Under Pressure. To really grasp the sheer variety of environmental stressors attacking our infrastructure, just look at the visceral aftermath of Hurricane Marie from back in August 2014 at the Port of Long Beach. On one side, you've got completely flooded Pier F shorelines, and on the other, a violently breached breakwater, which actually suffered 3 huge holes and multiple breaches. As you can imagine, access to rail operations and critical facilities was severely restricted. And the cost? That single weather event resulted in a staggering $28 million repair bill. That's $7 million for the shorelines alone and $21 million for the breakwater. It really drives home the severe economic vulnerability of port infrastructure to just one single localized disruption.
But the pressure on these systems is incredibly multifaceted. It's not just about coastal storms. Think about inland waterways. They are super energy efficient for transport, sure, but they're highly susceptible to drought. Recent hydrological disruptions along the Rhine River severely constrained vessel drafts and forced major operational delays. And on top of that, an increasing number of extreme hot weather days threatens to overwhelm power grids with blackouts and brownouts, totally paralyzing operations without a single drop of rain.
Moving right along to Section 2, Decoding Climate Resilience.
In the world of infrastructure research, this right here is your gold standard definition. Resilience is the capacity of a system to anticipate, absorb, adapt to, and recover from disruptive events. It's not just about, building taller walls. It is the ultimate goal of maintaining global trade continuity before, during, and after disasters strike.
So how does this academic jargon translate into actual port operations? Well, vulnerability is basically your low-lying terminal just sitting there exposed to a storm surge. Redundancy, that means having backup capacity, like using everyday industrial trucks you already have lying around to manually pull shut heavy fail-safe gates when the complicated drive tech breaks down. Adaptability might look like rerouting barges during low water, while flexibility is all about the rapid deployment of resources, like hauling out trailer-mounted mobile battery storage the second the grid fails.
All right, Part 3, Rising Tides in LA. The Port of LA has actually mapped out its vulnerability for the years 2030, 2050, and 2100. And they are battling a really complex two-front war here. First, there's permanent inundation. These are areas that will literally be lost long-term during normal everyday tide cycles, based on state guidance. Then you have temporary flooding, which are less frequent, rapid defense events that happen with storm tides during what's called the 100-year stillwater elevation, basically a combo of astronomical tides and storm surge.
To get ahead of this, the port proactively evaluates its shoreline using an overtopping analysis. It's a way to pinpoint the exact locations along the shoreline that sit at lower elevations than future water levels. Basically, they're finding the critical flood pathways before a drop of water ever crosses them. They evaluate the exposure, sensitivity, and adaptive capacity of all their assets so they can avoid incredibly costly emergencies down the line.
Becoming resilient isn't just a panic reaction. It's a highly calculated, phased strategy. Step 1 is heavy structural defense, raising areas, building flood walls, and installing pumping stations. Step 2 requires organizational command, linking police, fire departments, and specialized authorities with crystal-clear communication channels. And Step 3? That's about those low-tech redundancies we mentioned earlier. Things as simple as elevating your power distribution boxes and fiber optic junctions so they don't instantly short out when a few inches of water show up.
Next up, Section 4, Powering Through the Storm.
This quote from the Port of Long Beach really hits the nail on the head. Operations here are threatened by the exact same extreme heat and grid brownouts that are likely affecting your own home. Everyone's using more power.
Utilities are spending vast amounts of money responding to wildfires, and this aging grid makes reliability a massive challenge. And without power, a modern port completely freezes.
To solve this headache, the Port of Long Beach built an incredibly creative microgrid at their Joint Command and Control Center. We're talking DC-coupled stationary battery charging and massive trailer-mounted mobile batteries that physically drive power exactly where it's needed. Because space is at an absolute premium at a 24-hour seaport, they put their solar array 700 feet away. And get this, they actually secured special permission to build the only dual-customer microgrid in their utility territory, literally sharing power over the fence with a completely separate port pilot's facility.
All of this creativity is part of a larger strategy called the Zero Policy, Zero Emissions, Energy Resilient Operations. The real brilliance here is that the port is aggressively working to decarbonize and transition to zero-emissions equipment, while simultaneously establishing the critical energy backups needed to run that very same electric equipment when the main grid goes dark due to extreme heat.
And finally, Section 5, Future-Proofing Global Trade.
So, what is the next frontier for keeping global logistics running smoothly despite unpredictable climate shocks? It all comes down to a systems-based approach. We're talking about leveraging big data and Internet of Things devices for minute-by-minute weather monitoring. It's deploying AI and machine learning to predict exactly when infrastructure needs maintenance before it actually fails. And it involves building digital twins, basically virtual simulations of the port where planners can safely stress test operational disruptions and tweak their adaptability protocols entirely in a digital space.
The big takeaway here is that protecting our ports isn't just about pouring more concrete or building a taller breakwater. It's an ongoing, highly dynamic battle. It requires creating agile, forward-looking protocols that blend heavy infrastructure, smart technology, and really flexible organizational communication to manage these constantly evolving hazards.
We've got the framework, we have the technology, and we're absolutely seeing incredible innovations happening right now at the local level. But as global climate hazards continue to accelerate and become even more unpredictable, the big question is, will our supply chain infrastructure globally adapt fast enough? Or is the next superstorm going to wash away our progress? Thanks so much for joining me for this explainer. Keep learning, stay curious, and I'll catch you next time.